In 1954, the most advanced passenger aircraft on Earth started breaking apart in mid-air. Not because the pilots made a mistake, not because the engines failed, and not because the airplane looked weak. It failed because every single flight was quietly damaging the fuselage from the inside out. This was the de Havilland Comet, the aircraft that launched the jet age, and then taught aviation one of its hardest lessons. A machine can look perfectly normal right up until the moment it tears itself apart. When the Comet entered service in 1952, it was revolutionary. It was the world's first pressurized commercial jet airliner. It flew faster, higher, and smoother than the piston aircraft people were used to. To passengers, it felt like the future had finally arrived. But that future was hiding a problem engineers did not yet fully understand. The warning signs came fast. In 1953, one Comet was lost after takeoff during severe weather, and investigators initially focused on overstress. On January 10, 1954, BOAC Flight 781 left Rome and climbed out over the Mediterranean. Then the radio transmission stopped. The aircraft broke apart in mid-air. Everyone on board was killed. Just weeks later, another Comet suffered the same fate near Naples. At that point, this was no longer bad luck. This was a system failure. The problem was not one dramatic overload. It was repetition. Every flight pressurized the cabin at altitude. Every descent released that pressure again. That means the fuselage was expanding and relaxing over and over again. To the metal, it was constant stress. Every cycle pulled on the structure. Every cycle added strain. And every cycle gave microscopic cracks another chance to grow. That is fatigue. And fatigue is dangerous because it does not need one huge event. It only needs enough small ones. One of the most famous design details was the Comet's square windows. Sharp corners create stress concentrations. A pressurized aircraft cabin is basically a metal tube being inflated and relaxed thousands of times. If one small area carries more stress than expected, the crack does not stay small forever. It grows, slowly at first, silently, invisibly, until one day the structure can no longer contain the cabin pressure. And once that rupture begins, the failure is violent and fast. But this story gets even worse. Because de Havilland did test the aircraft, the testing created confidence that turned out to be misleading. The fuselage had been pressure tested beyond normal loads. Later, investigators realized this testing had changed the material behavior. A test is not automatically the truth. A test is only useful if it truly matches the real conditions the system will face. The consequences were massive. The Comet fleet was grounded, and the aircraft that had opened the jet age lost its lead almost overnight. But the disaster also changed aviation forever. After the Comet, engineers took metal fatigue far more seriously. Modern airliners became safer because the Comet revealed how dangerous invisible fatigue could be. That is why this failure still matters today. The de Havilland Comet looked like the future, and in many ways it was. But it also revealed that the most dangerous failures are invisible. Small stresses, tiny cracks. Until one day, the system runs out of margin. This is how systems really fail.